Hello friends, in this session we'll see the more examples from completeness topic and exercise from 3.2 of matrix space by P.K. Jain, Pawan Kumar Jain and Khalil Ahmed. Okay, so take the example. Let An and Bn be two sequences in matrix space XD. Let An and Bn be two sequences in matrix space XD such that D of A and Bn Xn is equal to D of A and Bn. Distance between An and Bn is non-negative real number. Tends to 0 as n tends to infinity in Ru or close open interval 0 infinity u. Then 1 An is Cauchy sequence. An is Cauchy sequence if and only if Bn is Cauchy sequence. And second, An is convergent sequence if and only if Bn is convergent sequence. An is convergent sequence if and only if Bn is convergent sequence. So first, suppose An is Cauchy sequence. An is Cauchy sequence. Claim Bn is Cauchy. Bn is Cauchy. So for this, D of in XD for this D of Bn Bm, I have to relate this D of Bn to Bm Bm to epsilon, where cosines of An and hypothetical sequence Xn, which is a sequence of negative real numbers converging to 0. So this is less equal D of Bn An plus D of An Am plus D of Am Bm 1. Okay. Is it clear? Now, N is Cauchy sequence. N is Cauchy sequence. Implies for epsilon greater than 0, fix epsilon greater than 0. Therefore, for epsilon greater than 0, there exists positive integer n0 or n1 belongs to n such that D of An Am is less than epsilon by 3 for any Mn greater equal n1. This is 2. Since Xn is equal to D of An Bn tends to 0 in Ru, implies for epsilon greater than 0 there exists some n2 belongs to n such that d of an bn minus 0. Absolute value if I take, it is again same as that. Less than epsilon by 3, less than epsilon by 3 for any n greater or equal n2. Using 2 3 in 1, 2 3 in 1, we get d of bn bm, d of bn bm, this must be less than epsilon for any n m greater or equal n naught is equal to maximum of n1 n2. Maximum of n1 n2, and therefore bn is Cauchy sequence. Is Cauchy sequence. Is it clear? Okay. I am keeping part of example here as it is. Solution is too simple. Now, for other way, if I assume that, now if Bn is Cauchy sequence, okay, now Bn is Cauchy sequence, claim An is Cauchy. For this, just replace A by B and B by A. An, Am, An, Am is less equal An, Bn, An, Bn plus Bn, Am plus Am, Bm. Am, Bm. We are getting this. Now, we are given Bn is Cauchy sequence. What we have given? Bn is Cauchy sequence. So here we'll get same thing. Bn, Bm. Now xn is equal to this. Since xn is equal to d of an bn, d of an bn, which is equal to d of bn an, right? Means this part. Okay. This goes to 0, means here we'll get d of bn am, bn am, or I will take an bn as it is. An bn doesn't matter. So goes to 0. Is it clear? And here I am getting bn am, bn am. That term is here. An, bn, bn am. This term we are getting here. Oh, sorry. An, bn, then bn, bm, sorry, bn, BM, and here BM AM. We want like this. We want like this. Now Bn is cosine, so I am getting this one. Okay, An Bn, Bm Am, that must approaches towards 0, no problem. Is it clear? So again from 2, 3, we will get An Am, An Am. This must be less than epsilon for any Nm greater equal N1, N2. And therefore, your An is Cauchy sequence. An is Cauchy sequence. So, observe solutions carefully. Just I am using triangle inequality, property of metric space, and somewhere symmetry property. Somewhere symmetry property. So, thus, hypothesis, triangle inequality, and symmetry property plays important role while proving this result. Okay. Now where to prove second part. Second. Okay. Is it clear? Suppose An is convergent sequence. Suppose An is convergent sequence in XD such that limit of An is equal to A. Limit n tends to infinity of An is equal to A. Okay. Then now claim Bn is convergent. So for this, d of Bnb, Bna, I am taking Bnb, Bna less equal d of Bn An plus d of Ana. Okay. This is one now. So say this is 1, this is 2, 1, this is 2, this is 3, sorry. Okay. So from 2, for given epsilon greater than 0, there exists n1 belongs to n such that d of Ana less than epsilon by 2 for any n greater equal n1. From 1 for epsilon greater than 0, there exists n2 belongs to n such that d of An Bn minus 0, which is equal to d of Bn An by symmetry minus 0, this must be less than epsilon by 2 for n greater equal n2. Okay, so this is 4, this is 5. Using 4, 5 in 3, from 3, 4, 5, we have d of Bna less than epsilon by 2 plus epsilon by 2 is equal to epsilon for any n greater equal n0 is equal to maximum of n1, n2. And therefore, limit of Bn is equal to B in X. Similarly, we can prove its reverse part. Means if I assume that Bn converges to Bn is convergent. Okay. Again, An is convergent, Bn is convergent sequence in XD such that Bn is equal to, if I assume that limit of Bn is equal to B, then we will get An must converge to A. For this, An B. So we'll get here An Bn Bn A by triangle inequality. By triangle inequality. Again same numbering say. Here we will get Bn A, Bn B here. Bn B less than epsilon by 2. From 1, d of An Bn, this less than this. Then d of Bn An B, An B, this must be less than epsilon by 2 plus epsilon by 2 for n greater equal n naught, and therefore limit of An. In previous one limit of Bn A पाहिजे होतं त्या ठिकाणी, that should be limit of An A, An is equal to B. Okay. In previous example, An A there. Is it clear? So in this way, this part is also proved. This part is also proved. Okay. Now we'll take one more example. So let N and Bn are Cauchy sequences in XD. Let An Bn be Cauchy sequences in XD. Metric space XD such that d of An Bn is convergent in Ru. D of An Bn is convergent in Ru or close open interval 0 infinity U. So that Cauchy sequence in metric space XD so that it's convergent. Okay, so we'll take this as an example. So for this, what is given, A and Bn are Cauchy sequences, and you have to show that d of A and Bn is convergent sequence. Okay. So for this, d of An Bn is less equal d of, I am taking d of An Am plus d of Am Bn Am Bm plus d of Bm Bn. I'm taking this. Okay. By triangle inequality, we'll get this. What this implies is d of An Bn minus d of Am Bm. This may be positive, negative. I don't know. If it is positive, it is less than d of An Am plus d of Bm Bn. If it is negative, then it also hold. So this must implies this is less equal to of Am plus d of Bm Bn. This is 1 now. This is 1. Now, since An and Bn are Cauchy sequences, since A and Bn are Cauchy sequences, in XD implies for given epsilon greater than 0, there exist positive integers n1 and n2 such that d of An Am is less than epsilon by 2 for any nm greater or equal n1, and d of Bn Bm, which is same as d of Bm Bn, less than epsilon by 2 for any nm greater or equal n2. This is 2. From 1 and 2. Mod of d of An Bn minus d of Am Bm. This must be less than epsilon for any nm greater or equal n0 is equal to maximum of n1 n2. This implies d of An Bn is Cauchy sequence in Ru. Right. Now, since Ru is complete metric space, therefore d of An Bn is convergent sequence. Every Cauchy sequence in Ru is convergent. Thus, hence proved. So thus, today we have studied examples on Cauchy sequences and convergent sequences. The relation between Cauchy sequence, convergent sequence with equivalent matrix. If D and D star are equivalent matrix, then that equivalent matrix also preserves Cauchy-ness of sequence, convergentness of sequence properties that we have studied. And then with help of that Cauchy-ness or convergentness property of sequences, what sequences we are getting in set of real numbers or set of non-negative real numbers, that sequences, how that are convergent, how that are Cauchy sequences, that we explain in this session. So with this discussion, today we'll stop our session here. Thanks for listening session carefully. Bye bye.